Okay, so we got problem 9.18. Says show that at a given frequency omega, the circuits A and B will have the same impedance between terminals A and B, and it gives us the value of R1 and L1. So it says find the values of resistance and inductance that when connected in series will have the same impedance as 4,000 radians per second as that of a 5,000 ohm resistor connected in parallel with a 1.25 Henry inductor. All right, so first what we want to do is we want to find for A, we got we want to find the Z equivalent. We got R1 plus L1 omega J. Then for Z2, we got it's going to be 1 over R2 plus 1 over L2 omega J, right? To -1. So we do the math here, and we get R2 times L2 omega J, R2 plus L2 omega J. And if we multiply this by R2 omega J, same thing here, our Z2 would look like this. Right? And then, yeah, R2 squared plus omega squared L2 squared. So if we split this, right, we'd have a real portion and an imaginary portion. We can think of this real portion as R2 or R1, since these two will have the same impedance, right? So 2 R2 plus 2 squared, R2 squared plus omega squared L squared. So, right, then we know that this right here equals this. Oops, that was ugly. Very ugly. Here, this over here. So, with this, we can conclude that they will have, yeah, that they would have the same values for resistance. So for inductance, we see Z1. So we go ahead down here. You see L R2 squared L2 over R2 squared plus omega squared L2 squared times omega J. Because we remember we have this here, this omega and this J. So then we can conclude that from this equal to that, right? So now it says find the values of resistance and inductance when they when connected in series will have the same impedance at 4,000. Yeah. So for part 2. So for this part, we're basically just plugging in numbers. So R1 4,000 squared 1.25 squared times 5,000 squared. R2 is 5,000 ohm squared plus 4,000 squared times 1.25 squared. So R1 is 2,500 ohm, and for L1, we got R2 squared, so 5,000 squared times 1.25 over 5,000 squared plus 4,000 squared times 1.25 squared, which is 0.625 Henry. So this right here would conclude this would be R1, 2,500 ohms, and our L1, our inductance, is 0.625 Henry.